Hello everyone, and welcome to the Dawn Missions webinar on the journey to the bottom of the world. I'm Joe Wise from New Road School in Santa Monica, California, and I'm one of the team, the EPO Dawn Education Public Outreach member team, part of the team. We're here at Mid-Continent Research for Education and Learning in Denver, Colorado. And at this time, I'd like to thank our host here at McREL, Judy Conley, who is the new media coordinator here, Glenn Taylor, the Director of Information Systems, and John Rispy, a principal consultant and also a member of the Dawn EPO team. I'd like to warn you a little bit ahead of time that there might be a little bit of a delay in the slides. This is our first attempt at doing a webinar, and we're looking forward to using this as a part of our Dawn EPO to disseminate much of our information out to a wider audience. At this time, it's my privilege and honor to introduce our speaker, my good friend, Dr. Lucy McFadden, professor at the University of Maryland. She has spent much of her career exploring surface compositions of comets and asteroids to add to our understanding of the origin of our system, our solar system. She's also a Dawn Mission Co-Investigator and Science Team EPO lead. Dr. McFadden.
Thank you, Joe. And thank you all for joining me today. It's very exciting to have so many people be here with us out in webland and here at McREL. I appreciate the local audience and the extended audience of over 200 of you out there. So I want to share my journey, and I had a privilege to explore parts of the world that many people, few people get to, and so I love sharing my adventures. I also was inspired by this trip, or my excitement about exploring the solar system was renewed because I had the opportunity to experience the Earth as a planet. And I'm sorry that we cannot, at this webinar, take this world map that you're all looking at and show where everybody out there in webland is. But you are literally all over the world, from Turkey, Canada, and all over the United States and various places. So, but maybe next time we will be able to highlight where everyone is from on this world map. Now, I started in Washington, D.C. Right after Thanksgiving of last year, and began my journey to go search for meteorites in Antarctica with a research team that has launched expeditions since 1976. So I was going on my personal adventure to the far reaches of our Earth, but I was going with a very experienced team for the purpose of finding meteorites that bring us information from the solar system without our having to go there. So the meteorites are debris from collisions in the solar system, which are in orbit. The debris from these collisions are orbiting, they're rocks orbiting the sun, and they happen to get moved into an orbit that then coincides with the motion of the Earth around the sun. And so these meteorites collide with Earth. Now, they land on Earth literally all over the globe. But there's something special about Antarctica that allows us to find them, and with the support of the National Science Foundation, we collect them and return them to Houston, Texas for further scientific study. So let me tell you about my journey, and along the way I'll remind myself and remind you why we are doing this and what it tells us about the solar system. So the team met up in Los Angeles. We flew to Christchurch, New Zealand, over on the far right, lower right side, and there we prepared to go to Antarctica. Now, the first thing you need when you go to Antarctica is warm clothes, and the Antarctic Research Program provides us with our cold weather gear. I am here fiddling with my zipper, and it reminded me that, took me back to kindergarten immediately, that here I was going out into the cold weather. I had to learn which coat to put on when, which hats and gloves to wear, and I had to be sure to have my boots on. Now we got to select our clothes, and so we had many choices things to choose from. I had to be sure that my boots weren't too tight, and luckily my feet were never cold because my boots weren't too tight. They gave us socks, and we had many different pairs of gloves to choose from and different hats. But throughout the whole 6 weeks on the ice in Antarctica, I constantly had to learn which hat to put on and how much time it took me to get my clothes on to go outside. So I wished in hindsight that I'd had that insight when my kids were going to school, and I would have been more patient with them if I'd realized that they were learning about the cold world out there. Next slide. Now we have, I was ready to go, and we're getting ready to fly. I was limited on what I could take. I did have another suitcase and a duffel that was on the plane, but this is my boomerang bag that I had to take with me on the plane, and they monitored the weight because I'm flying on a C-17 cargo ship that is flown by the Air Force, U.S. Air Force. And getting on the plane was quite a spectacular experience to see this huge cargo plane. And I immediately noticed that there weren't any windows, so I got on the plane and realized I was cargo, but I asked the flight engineer if he'd give me a barf bag, and he said, oh, sure, because none of us wanted to clean up. Luckily, I didn't need it, but I was happy to have that with me. I was really sort of like a deer in front of headlights. I didn't know what to expect, and so I just followed everybody. I sat next to, I'm down at the end there with my headphones on. You can't really see, but I sat there writing in my diary. I was listening to my iPod and some of my favorite songs. It turns out I was listening to Saturday Night Fever, and my favorite song turned out to be Staying Alive. So next slide. After a couple of hours into the trip, I had got up the guts to look out the window and take a picture out the portal. And there, 4.5 hours out, we were over the continent of Antarctica. And I want to remind you, this was in the end of November, this is about 70 degrees now, south latitude, and it's in the summer. So it was Antarctic summer. The sun never set. We are flying over the Antarctic continent. It is a land mass that has mountains, but it is snow and ice covered constantly. So there we were, and I just felt, oh my gosh, you know, there's no turning back, and I felt a sense of the vulnerability of us as humans. This is not a hospitable environment. Then we were getting ready to land at McMurdo Station. Now what you're seeing here in the upper left corner is a blow-up of the town of McMurdo Station, which is shown in a less exploded view on the lower right-hand side. What I want you, and I'll take you in town with my pictures in a minute, I want you to notice the gray stripe from the left, middle left, going down. That is the ice runway that is prepared for the jets that fly into McMurdo, bringing cargo and researchers, scientists, and their support staff into McMurdo. And then you can see the parking lot and the road from the square rectangular parking lot over to McMurdo itself. The plane landed. The pilot said it's cold out there. You know, there's a song for that. I'm not going to sing it, but you all can at home. And I zipped up and got my hat on. And here's one of my teammates, Marie Keiding, who is a graduate student in volcanology from Denmark, but she was studying volcanology in Iceland. Now, she likes the polar climates and was happy to get out of Iceland because the sun was not rising in Iceland in November and December. So she came down south. She was my Antarctic mentor and tent mate, and I was very appreciative to have an experienced person who'd been to Antarctica before as my buddy. So we were then on the ice, and we needed to get into town. So there were very unusual vehicles in McMurdo, and this one called Ivan the Terrabus brought us into town. And here I'd like to introduce you to another one of my teammates here is Dejun Tan. He's a Chinese graduate student from China originally, but he's at Case Western University in Cleveland, and is a graduate student of the team, the head of the Antarctic Meteorite Search team, who is Ralph Harvey at Case Western. So we went into town, and now I'm going to show you around town a little bit. So it is a town. It's like, this looks pretty much like a frontier town. And in the summer, the ice melts, and this ground there is a volcanic cinder cone, because across the bay, you can look out across the bay, but you can't see it here, is an active volcano, Mount Erebus. So this is volcanic cinder cone that's millions of years old, but it's from the nearby active volcano. And there were scientists down there studying the volcano. I met lots of interesting scientists studying things I'd never even thought of before. I had thought of volcanoes before, but I met someone who studied seals and actually went swimming with seals to study their habits and lifestyles. So I'd never thought about someone actually going into the water in Antarctica. But around town we've got fuel tanks. There are a set of 4 barrack-like brown buildings that were the dormitories. They're bunks, and I was in a room with 4 bunk beds or 4 bunk beds and lots of, in one room. It was just like summer camp, but we had heat in the cabins. There's a hospital here which has the red roof. There are green buildings there, which must mean something, but I'm not quite sure. There's certain type of buildings, but I was only in McMurdo a week, getting my training and preparing for our expedition, which went out of camp and out onto the ice, as we said. There's also a research lab here on the lower left. But we had to, and look at all the cargo there that's sort of in the center. That's all the cargo for the various field expeditions. And this logistics of bringing our gear and our food and tents and everything is what McMurdo is all about. There are about 1,000 people in town supporting about an equal number of scientists going out all over the continent for a whole range of scientific expeditions. Go to the next. The National Science Foundation has an administrative building because they sponsor the U.S. research that goes on. We do host other scientific expeditions from our collaborators from other countries. When I was here at the time, at the beginning of the season, only U.S. teams were in town, so we flew, only the U.S. flag was flying. Next, please. We had training on snowmobiles because when we were put out in the field with our snowmobiles and our tents and all of our foods, and the snowmobile is our means of transportation. So I was trained in about an hour how to drive and maintain my snowmobile. And then we set out for a day of an overnight from McMurdo to practice, and it was a shakedown trip. So we went out and set up our tents, and carrying out the theme of here I am experiencing a new environment and bringing my cultural practices into a new environment. I have no idea why I left my boots outside of my tent. I was expecting to get my tent dirty. I don't know, the snow. So I'm still laughing at myself that I actually did this, and believe me, I only did it once. And actually, I think I figured it out before I went to sleep. So this is a Scott tent. It's a 2-person tent. It was designed by Robert Scott, who was a polar explorer in the 19th century, and we've used new materials, but the design is the same, and it's triangular, and there's a little hole that you climb in and out of. We are trying to, as the people that go to Antarctica get older and older, we really don't like climbing in and out of that little hole, and we're trying to figure out how to design a door that has easier access, but yet still allows us to close it down and close off the cold weather from outside. Let's go to the next. We were also on our shakedown trip out there for some safety training. Now this is John Scott, who's our team leader and mountaineer. He has been doing this for over 25 years, and as you can see, he's been wearing the same pants for 25 years, and the same hat, too. And John gave us training for crevasse rescue, because out here on Antarctica, remember, it is a mountainous land mass, and we're in cold conditions. There's snow that falls constantly and gets compacted, and there's a lot of cracking and motion of the glacial ice. And they do form cracks, large cracks called crevasses, and believe me, we try and stay away from them. Your natural instincts is to see one and go the other way, but we still had to learn how to rescue somebody in case somebody fell in by mistake. So we did have a day of training with ropes and pulleys and our axes, and our simulation involved John being the one who had to be rescued. And so we had to, here was a great exercise in teamwork. You have 8 people out in the field. You have maybe 4 people who've been there before and know what they're doing, and only 2 who are really skilled mountaineers, and they're the ones that are out of commission. And you have to appoint a leader and figure out how to rescue your leader, because you really want him, because it's so much easier to follow directions than to figure things out yourself. So we rescued John. It took us about an hour and a half, and he was down in this crevasse, which we didn't know, but he was sort of lying around in the sun, but he was down out of sight from us, so we did go through this exercise. I was happy when that was over, and we went back to McMurdo and got ready to ship out onto the ice. Now, the one last thing before we shipped out was getting our food, and here we are shopping at the McMurdo grocery store, taking our food and planning our meals for 6 weeks. Now, I have a challenge planning my grocery shopping for a week, but doing it for 6 weeks, and Ralph said, oh, just do 1 week and repeat it. So we collected our food, put it in these food boxes where they stayed frozen, because sometimes the sun rises and can heat things up. So we kept them frozen. We had great food, and I'll tell you a little bit about that later. Let's go to the next one. Now here we are. Remember, why am I doing this? I'm having a great adventure, but we are out here to look for meteorites, which have brought us samples from the solar system. So this map of Antarctica shows dark circles where previous expeditions have gone in Antarctica to look for meteorites. It turns out that they collect in certain areas. Now, meteorites are hitting the Earth all the time, so there's nothing special about Antarctica that says all the meteorites should land in Antarctica. They don't. They land all over the Earth. But in Antarctica, it's a landmass. There are mountains, and glaciers are still under the force of gravity. And so the ice at the highest points on the continent move slowly downhill. And actually downhill, here's the South Pole, downhill ends up being toward the ocean. So when the ice on its path, on its trek downhill, it has collected these meteorites that land all over the place, right? They land pretty much uniformly. And the meteorites have landed over millions of years too. In fact, most of the meteorites in Antarctica that we found so far are 1 million years old or less. So they've been collecting there in the ice. The ice moves, but it comes up against this mountain range, the Transantarctic mountain range, and that's a barrier. The ice ends up flowing around the barrier or changing its direction, but the meteorites get trapped behind a barrier. So we go out to these barriers looking for the meteorites. Now those are 2 steps. I'm not going to give you the complete explanation until we go to a few more slides. But we're going out to the Miller Range, which was 150 kilometers from McMurdo. We go out in a smaller plane. A C-17 doesn't have a long enough flat space to land without a crew to build a runway. So we took a DC-3, or also called a Bassler aircraft out into the field, and it took 3 trips to bring the whole team and our snowmobiles and our gear out there. It was about an hour-and-a-half trip, and here we are out in the Miller Range. I didn't know there were places in Antarctica with place names before I left, but here's the Miller Range, and I was glad that the pilots knew where we were going and that they had GPSs and could get there. These mountains, okay, so we're landing, the planes drop us off, and we unload our gear, and the planes have other things to do. They're supporting everybody out on the continent, so they land, drop us off, and take off. We collect our gear and get into our wagon train and head off to our campsite. So this looks like a good place to camp. You know, why not? Well, John's been there before, and he figured he selected our field site because of the terrain we wanted to cover. So we put up our tents, and here you can see the full size of the Scott tent, and triangular, not much room. And I'm out here. The planes have left. I realized the planes left before we got home, before we got into the door. And that really bothered me, but so we were putting up camp quickly, and not only did we have to get the tent up and our stove set up to turn on the stoves for heat, but then I had to go out and chip ice to melt it so that I would have some drinking water. And so, and here we are on the ice at an elevation of about 7,000 feet. Okay, so it's a little bit higher than Denver, but it's sort of like being up in the foothills of the Rocky Mountains. And so I got thirsty pretty quickly. So dehydration was an issue. But we got set up and got everything in order and had something hot to drink. And you know, that took a whole day. And then we went to bed and then I, you know, we're talking, getting used to things. I wake up in the morning. And how do I get up in the morning? Well, John comes and wakes us up, and it's just like my dad did when he was waking me up for school. It was great. I could hear him walking from his tent. I could hear the crunch of his feet in the snow. But that first morning, it was really noisy. The winds were up, and he says, "Well, it's about 4 degrees below zero, and the winds are about 30 miles an hour, and we're not going anywhere today." So we stayed in the tent. So I was happy. And I organized everything, and here's my tent. You know, welcome home to my house. The tents, the gas stove's in the middle. Gas stove was always on when we're in the tent. When we leave, the stove goes off, and when we go to sleep, the stove goes off. That's a safety feature. We had plenty of thermoses to keep our water, keep a supply of water, but I had to plan ahead. When do I melt the ice, and whose turn is it to go out and chop the ice and bring it in a bucket and bring it inside? So getting around and living there took some getting used to. So when we had this first storm, the first day, oh, and I figured out where to hang my boots so they were nice and warm in the morning. This was one of the pleasures of Antarctica that I hadn't anticipated, heated boots. And we hung our washcloths to dry too. So that first morning when I woke up and when John told us that it was too cold and windy to go out, I was actually relieved. We had lined up our food cases, our river boxes, to protect them from drifting so that we wouldn't lose them. And that is indeed Ralph Harvey coming and checking on us. I really did appreciate, well, I was very appreciative that I had a veteran in my tent with us. But then I said, well, is Ralph going to check and make sure everything's okay? But now, remember what we're here for. I've got to watch my time, and we are here to find meteorites. So let's go ahead and see. The weather did clear up. I had to use my head. I know that that storms come and stop and start. It did clear up, but look, we had to dig out our snowmobiles, and that took us all morning. But we did that, and we were all ready to leave, or getting ready to leave, and go out and find meteorites. And Ralph had to teach us. Now, how do you find meteorites? We go out and look. We practiced. I said, oh my gosh, this is where we're looking. How am I ever going to find meteorites here? There's, what's the trick? Ralph, tell us. Well, so we practiced close to camp first. We went out walking around camp and walked up to all the little rocks. Now, there are rocks because there are mountains, right? So rocks fall off the local mountains. So the first thing, you have to learn what the local rock looks like, and Ralph taught us that. Then we got ready to leave camp after our training nearby, and we did find some. It took about 20 minutes to find the first one. But then we got ready to leave camp and cover this terrain uniformly and systematically. And we were getting ready to leave camp, and I said, John, I've got to ask you a question. And Ralph said, always ask questions. And that's a key for teamwork, is be sure to ask questions and don't be afraid to ask questions. I said, I know the answer, but I have to hear you. Because here we were sitting here setting out to leave camp. And where are we going? I said, John, you do have a GPS, don't you? And he was so surprised because I was worried we'd get lost. I mean, what if we can't find our camp? And he looked at me and he said, yeah, I've got a GPS, but I don't know how to use it. I said, oh, okay, come on. So with that, I laughed and I said, let's go, let's get out of here. So we took off and went out on a hunt now John had a map, so he knew where we wanted to go and where we'd been before. So we went out and lined up and said, okay, this is where we're going to search. And we used flags, and we'd mark our flags where he'd marked a flag of where we'd been the last time. We had to go find that and then go find our next position. And then we'd ride in our snowmobiles, 8 abreast down for a couple of 100 yards, pivot around one person, and then ride back. So we were searching systematically, and we had to look at every rock we could see. Now here you can see there aren't many rocks here, but we'd stop when someone thought we'd found one. Let's go. If we thought we found a meteorite, we called everybody over, waved our arms, and we went over and looked and examined the rock. And if it was a meteorite, we would pick it up with tongs and put it in a Teflon bag and mark it and wrap it up very well. And then we planted a flag where we found a meteorite. So we could look back and see how many meteorites we'd found. And so that it was very satisfying to see flags like this, and we were here probably breaking for lunch. So there were some places weren't always these ice fields that were wind blown. That's the other thing I was going to tell you. Once you get a meteorite up against a barrier, so we did go to this barrier here, which is a moraine, which happens to have lots of other rocks. But once up against the barrier, it's the constant blowing of the polar winds that blows the snow and ablades the ice. It blows, and it's so cold that the ice evaporates. And then you get this concentration of the rocks that effectively come to the surface. They don't literally rise, but the ice is blown and eroded away. So then you can find a strewn field of rocks like this, but here we had to look closely and separate out the regular rocks from a meteorite. And so those of you out in webland, I really haven't forgotten you, but now you can sit here and search for a meteorite yourself and answer the question yourself of which meteorite you think which rock you think might be a meteorite. So does anyone here in the audience want to hazard a guess? So I can give you clues, because the black one, right, because the black one sort of in the middle there. It is black because it has fusion crust on it. Fusion crust is a thin, glassy rind that occurs on meteorites when they're traveling through the atmosphere. When they're coming through the atmosphere, the friction with the atmosphere heats up, and the meteorite will melt just a little bit at the outer edges, and you get this dark fusion crust. Now sometimes the fusion crust isn't dark. It depends on the nature of the rock. Now the next couple of slides I have some examples of some of our finds, some of our treasures. Now each one of these rocks, each one of the meteorites tells a story about processes in the early solar system. And I don't have time to go into all the stories, but here I also don't want to go in using a lot of technical terms that everyone might not be familiar with, but I will leave you at the end with a place where you can go in and find out more information about the different types of meteorites. This one, though, is a carbonaceous chondrite. and again, we recognize it because this one's really irregular and jagged. And it does, I see a little bit of fusion crust on it. So let's go to the next one and just compare the differences. See how these rocks all look different. Here's a nice black fusion crust. One of my colleagues noted, well, this comes from our logbook, because when we collect them, we say, we take notes. And this one might be related to a meteorite that had this name, Allen Hills 84001. It was found in 1984. And we determined that it came from Mars. So we do actually have samples of Mars from here on Earth in our meteorite collection. We are wondering if this might be another sample of a rock from Mars. Let's go to the next one, which has a lot of a green mineral. This is a real rock. And yeah, no, it's not kryptonite. It's the mineral called olivine, also known as peridote, as a gem quality version of olivine. And again, this may or may not come from Mars. We do not do any scientific analysis out in the field. We're merely collecting the samples and transporting them back to the laboratories in Houston, Texas, and then distributed around the world. This one, someone thought might be a lunar rock at the time, and there were some experienced people who have indeed looked at the lunar rocks that have been brought back by the Apollo astronauts. I didn't say anything at the time, but my bet is not, because we were on a moraine a little bit earlier, and there was lots of bedrock that had these large white crystals in it. So I think this is a local bedrock. Here's just another larger rock. So this one's about 15 centimeters long. Again, it has a fusion crust, and I'm not going to say any more about that, but let's look at a couple of the others. At the end of the day, we would collect all the rocks that we'd put in our backpack and put them in bags in the freezer container to keep it cold, so we wouldn't get contamination from any snow that might have been attached to it. And we keep it frozen until we get it back to Johnson Space Center in Houston, Texas, where the meteorites are cataloged and curated and then distributed to scientists around the world. And when we send these back, we put in our leftover chocolate bars that we haven't eaten, because the people in Houston have to cut open these things. We're cold and we wrap them up, and we don't want them to get we get carried away in the field wrapping them with tape. Let's go ahead. Now, we love looking for rocks, but you can't look for rocks all the time. So we did have opportunities for some recreation and entertainment. Marie brought her skis. Notice her white patch on her ski mask. She got frostbite the first day, so she had to cover up. So she went skiing. We also played a little softball with a cricket bat. People from previous teams send us goodies down there. We did have, I had plenty of time to read. I brought a couple of my books, and we shared books and passed them around, and before long we had a book club. We were sitting there discussing things. Let's go on. We have resupply, so communication from the outside world happens a couple of times during the season when the planes come in and bring us more gas for our stoves. They bring letters, they bring food we've run out of, they bring us fresh food that had been shipped in from New Zealand. So we're happy to see these guys. John goes up and shakes hands for the whole team. It's a day. It takes a whole day to have the resupply come in. And I just want to make a note here, whereas I was predisposed to take pictures of these handsome young pilots, there were gorgeous female pilots too, and so the guys had a good time, and I just want to be sure, I mean, they were happy to see them. I didn't mean what I said. They were happy to see the attractive women, and my point, because we are educators here, my point is please encourage the young women who want to be pilots that there are opportunities. I just took pictures of the guys. And they brought mangoes from New Zealand. So here I am in Antarctica enjoying my mangoes. We had parties weekly. We would have a potluck supper in the party tent. It started out being a shower tent, but nobody wanted to take a shower in Antarctica. We just did sponge baths. And then we turned this into a party tent, and we had a stove, and we were able to celebrate and decorate for Christmas time because of our previous, the people before us had sent us our gifts, our Christmas gifts. After a couple of weeks, though, we started the isolation and the cold weather started getting to us, and we all dreamed about bringing home a big meteorite, but John wouldn't let us. John said, "Back away from the rock." And so we were happy. We loved our time out there. We brought back 710 meteorites that we collected in 40. Well, we had 22 good days of weather to search, and we had about an equal number of days, or a little less than that, of days of bad weather, and then days for cleaning up and packing up and greeting the people coming to us. So we were looking forward to going home, but we had a tremendous experience. We all appreciated the beauty of Antarctica. We didn't have nice sunsets, but we had nice weather patterns that we could take pictures of here. And I was amazed at the ice here that has ripple patterns in it, just like water. It is driven by the wind, and it is astonishing. But we had to leave eventually, and we had to take down our tents and close up camp. And here's Ma and Pa Antarctica in our Antarctic Gothic shot, wishing everybody farewell. We were happy to see the airplanes come back, the planes return to come get us. And I was telling a pilot as I left, I said, we get so excited when we see the planes come in. And it is, I mean, it is beautiful, the white planes, red and white planes against the blue sky. And the pilot said, yeah, we get excited when we find you, too. I go, oh, great. So we had cleaned up and closed down our camp, and we left our camp the way we had found it, perfectly clean, and headed back to McMurdo. And back in McMurdo, it's the end of the season. It's the sun is beginning to set, and people are ready to go home. Believe me, we were ready to go home. And all of these countries had we had collaborators from all these countries in McMurdo. And it was fun to come back and tell about our adventures. I mean, we loved talking to each other and explaining what we'd been through and what we were doing. And then this is a statue of William Byrd, who was one of the early U.S. explorers to Antarctica. And then in the background is the ice-breaking ship, this is where we landed when we came in. The runway was moved to a place where it was colder when I flew out to the ice, because in the summer the ice melts. Now here the icebreaker is keeping the pathway open and keeping the ice from freezing over until the cargo ship comes in and brings all the gear and brings all the supplies for next year. So they were getting ready the ship was on its way. They wanted us to leave, and we were ready to leave. So we had, we packed up our gear and hopped the next plane out of town, which leaves every 3 days, weather permitting. So we had a chance to leave. And this time I was comfortable with my camera, and I took this picture myself, and I went up into the cockpit. We were allowed, the pilots let us come up into the cockpit and look out and get their beautiful view of Antarctica, and I don't know whether I'll ever be there again, but I did feel at home there for about 6 weeks, but I was very excited and ready to go home myself to my family, and oh yes, I did have to get back to work. So I want to remind you all leave you here with this satellite image of Antarctica, the continent that is devoted to scientific research. My experience finding meteorites, searching for meteorites, inspired me to continue exploring, understanding the meteorites themselves, and pairing that with my exploration with the spacecraft that travel to these objects out in the solar system. Let's go to the next slide. I was the Dawn Patrol, my space mission to Vesta and Ceres, two of the largest asteroids in the solar system. I went looking for fragments from these large asteroids, looking for fragments that have collided with them on Earth. I think we might have been successful in finding some samples from the asteroid Vesta. I was really looking out for samples from Ceres, which is a dwarf planet and the largest main belt asteroid. So I was interested in looking for those meteorites, but I'm not sure what I'm looking for. And as far as we know now, we do not have any samples from Ceres itself, but maybe we'll find some. Maybe someone in future expeditions or in the material that we brought back, there may be something from Ceres. But we'll have to explore, and it'll take us time to determine that. So I want to thank everyone for joining me. We're going to take a few minutes here to take questions from the audience here. And I'd like to, for those of you who haven't taken the opportunity to ask questions, I have a website here. You can email at askascientist at this website and send me questions, and we will make an effort to answer you out in webland. And you will probably ask some very good questions that we will post on our frequently asked questions section. So I do appreciate questions that come up. If perchance I have inspired you to learn more about meteorites yourself, or engage any students you work with, or family, friends, nieces, nephews, in an activity that will allow you to identify meteorites, even if you find something and it looks weird to you, please check out our web activity. We have a little tool that will guide you through the process of understanding what a meteorite is and allow you to develop, make some tests. And this is an interactive tool that was developed by my colleague Horton Newsom and his students at University of New Mexico. So please take a look at this if you're interested, and I think we'll take some questions now.
Okay, thank you very much.
And those of you in Webland, please don't go away, because maybe the questions, you'll be interested in the questions that our audience will ask.
Thank you very much. And are there any questions in the audience that we could field? Yes. Well, no, we have a procedure. They actually, the question was, how did we contain the meteorites that we found? Yes. No, we had a procedure. We picked them up with tongs, and we did not touch them, and we put them in Teflon bags. And then we wrapped up the Teflon bags, put a number in it to mark it, took a picture of it, and wrote notes about it, and then we threw it in our backpack. We had a collection backpack, and so we put those in every day. And then we had to log them. So it was a big, it was quite an involved process trying to catalog them and keep track of them and make sure that we didn't lose any, or that we could account for all of them. Yes.
If I understand this correctly, other than days when you had resupply days or some sort of dedicated day, you literally got up to go get rocks every day?
Yes. The question was, did you really get up every day and go look for rocks for 6 weeks? That's a great question. Yes. Our main objective was to search for meteorites. And we did get up and try and leave at 9 and come back around 5. Our main objective was to look for meteorites. So yes, we did. But we also had other research projects involved. We went to look for other types of rocks. We were trying to date. There was a project that had been approved. All research projects have to be approved by a board that supervises activity in Antarctica. So we had 3 other projects that we did in and out, but they were secondary.
Lucy, I'm fascinated by the things that you discovered about human side about putting the boots outside of the tent and things like that. And the thing that I thought of is, as you were packing up to go back home, it's typical, custom, when you go on a trip to bring back souvenirs for family members.
Right.
So I'm wondering, out in this area of ice and snow, were there things that you brought back, or is it, I mean, you brought back these pictures, but things for your family members?
Right. Okay. So the question is, what souvenirs did I bring back from Antarctica? Now that's a great question because it was very difficult. Well, first of all, remember Antarctica is governed by this international treaty, and I am not allowed to bring anything back from Antarctica. So I did not bring anything back, even though there were no plants or animals to bring back. I could have brought back rocks, but you're not supposed to bring back, you're not supposed to take anything from Antarctica. There was a store at McMurdo, however, and so what did I buy and ship back home? I brought Antarctica hot sauce for my husband. I bought myself an Antarctic ball cap, and I'm sorry I'm not wearing it today, but people in Webland can't see me, so I don't have to look like a fool. I bought chocolate from Antarctica. No, the chocolate must have been from somewhere else. But chocolate was a very important food stuff down there because it has a lot of energy. And let's see, other souvenirs. Yeah, I have coasters at home from McMurdo Station, and a T-shirt, of course. So the store at McMurdo allowed us to fill our need for souvenirs. And I sent Christmas cards, people getting, I'm sorry I didn't have everybody's name and address, because I could have sent you mail from there.
Lucy, we have one question from out in Webland. How would you know material might come from Vesta or Ceres?
Well, that's a very, how do I know whether material comes from Vesta and Ceres? That takes, the whole study of meteoritics addresses that. It's basically through laboratory studies of many different attributes of these rocks. We know that we have rocks in our meteorite collection from Vesta because about 1 in every 7 meteorite we find has characteristics. It has a signature, a reflected light signature of 1 in every 7 rocks has the same signature as the reflected light signature of Vesta as I view it through a telescope. That's one indication. Then there's a whole series of additional evidence that we look at Vesta. There's a huge basin in the southern hemisphere of Vesta. There are fragments that have been ejected into the solar system from Vesta, and there's a mechanism that brings it back here to Earth. Now, how would I know if there's something from Ceres? I'd have to think about that. We don't know much about Ceres right now. The spectral signature of Ceres does not match anything we have in the meteorite collection. So that's what tells us that we think there's nothing from Ceres. But it is an involved process, and it's taken 20 years to be reasonably certain that we've got materials from Vesta. No astronaut has ever been out there to bring anything back from Vesta. So it's all a series of suggestions and theories that and evidence, scientific evidence that supports that.
I have another question from the web people. Do you note the GPS coordinate for each sample?
Yes, we do. This is where we're missing an elaboration. Okay, yes, we do record it. In fact, John's snowmobile had a post on it, and that's his GPS. Surprisingly, at any one time, there were about 14 satellites that were above the horizon. So we were able to get our geographic position for each of those meteorites that we found.
Okay. Another question comes in, do any opportunities exist for undergraduates in Antarctica?
When I was down there, there were seminars, webinars, and activities for school children. I am not aware of whether or not undergraduates can go. I'm not going to say no, because the National Science Foundation has the Polar Research Program, and if an undergraduate is interested in going there, I mean, I would counsel an undergraduate to stay in school and get good grades so that you can then go as a graduate student. So in our expedition, we had graduate students and scientists only.
How many were in your team?
There were 8 of us in our team. How many people were in our team? The team was 8 people. There were 6 guys and 2 women, but that changes depending on who's available and who's interested in going. And we didn't know each other beforehand. Well, I knew one guy professionally. I'd known of him from his research. But we worked well together. It was a fun time, and we had this common experience, and we had to look out after each other. So it was very satisfying to have this teamwork involved. While at the same time, it was also very lonely because there weren't that many opportunities to interact. I mean, we would invite people over for dinner to our tent, but that took a lot of effort, and we were exhausted at the end of the day. So we didn't do that every night. Just like at home, you don't do that every night. Yeah?
What was the typical daytime temperature?
The question was, what was the typical daytime temperature? One of the grad students, Dejun, actually was taking temperatures. And so if we didn't have a storm, the temperature really was about, well, it was in the 20s Fahrenheit. So it was, plus or minus 5 degrees. So it was cold. One day we got back early and had a party. We dug a snow couch, and we sat around and had a party. And it was a beautiful sunny day. It reminded me of spring skiing in Colorado. But the party lasted about 20 minutes because it still was really cold, and you just couldn't sit around. So. Let's see, we've got 5 more minutes. Too bad I don't have backup slides to show more pictures.
That one story you mentioned.
Maybe we could be flipping through so people can see again.
That one story you mentioned about how we knew the meteorite was from Mars.
Ah, right. Okay, well, another question, a good question to ask, or that one of my colleagues asked, was how do we know that the meteorites we have from Mars are indeed from Mars? And this is an interesting story that took years to find out. There were these, as I said, there are about 40 or 50 different types of meteorites. There was a special class that we called SNCs, and I don't even want to go into it. There was a special class of meteorites. We knew that they had been heated and melted. They were igneous rocks. But when we measured their ages, they were very old. Well, all the rocks are very old, but these particular rocks were not as old as all the others. And we said, well, gee, if this rock is only 3 billion years old, it must have come from a large body that could have supported volcanic activity in its lifetime, as opposed to early heating when the solar system formed. So it was a relatively young rock. And then we said, well, where is this parent body? Then when we went to explore and send spacecraft to Mars, we measured the composition of the Martian atmosphere and the proportion of various gaseous elements in the atmosphere and their ratio of their isotopes. Then one day, someone was exploring one of these SNCs meteorites and found a little gas bubble in the meteorite itself. And they said, oh my gosh, if I can measure the gases in that bubble, there might be, if there's gas in that bubble, then that will tell us something about where this rock came from. And we know what the gas composition is of the Earth, and now we knew what the gas composition or the ratio of gases in Mars was. And so the final evidence that these SNCs meteorites are from Mars is because the gas isotope ratios in this little gas bubble in that rock is the same as it is on Mars. So it takes a lot of a little CSI activity to figure out that indeed we do have samples of Mars here with us.
Okay.
And I still have a few minutes because season before mine we did find a new meteorite type. I sat out there on the ice saying, why do we keep coming back year after year after year? But we do it because there is potential to find bodies, find rocks from other planets. But last season, in 2006, they found a new meteorite type from a body that's not a planet that we know of. It's another body that was at one time almost the size of, probably the size of the moon, and has similar characteristics of the moon, but its isotopic signature is decidedly different from the Earth, Moon, Mars, and everything else that we know of. So we have indeed found evidence for other small planetesimals or protoplanets that are out there in the asteroid belt. And that's very exciting. That keeps us going.
Okay, we have about 3 minutes left, and there's an inquiry about an update on the Dawn mission.
An update on the Dawn mission. The spacecraft heading to the Dawn mission of Vesta and Ceres launched in September of 2007 from Cape Canaveral, and it is on its way to Vesta and is chugging away. This is a mission that has an ion engine which constantly propels itself through releasing xenon ions out the back, and pushing the spacecraft goes in the opposite direction. And it's constantly accelerating. So the spacecraft now should be cruising, and it is. It's under its ion energy. We have a flyby of Mars scheduled for this coming February, and the spacecraft will get to Vesta in February of 2011. And then it will go into orbit around Vesta for 9 months and then go off to Ceres and orbit it, and it will continue to operate until 2015.
Okay, and we have one of our
Thanks.
field testers for the Dawn EPO has asked us a question. I'm amazed at how many meteorites were found in just one expedition.
Right.
Is this the norm, or did you have good hunting?
Oh, well, both. We had great hunting, 710 meteorites. It wasn't a record. In fact, we wanted to, John had to, our guide had to keep us in check. He had to keep us safe because we got into this mind frame of we want to find more and more and more. And he said, you know, no, you've got to stop. It's 5 o'clock. It's time to go take care of yourself. Let's go home and quit looking for rocks, quit looking for the meteorites. But we have, over the more than 25 years of these expeditions, we have found over, I think it's 21,000, 22,000 meteorites. So we've really expanded the volume of extraterrestrial material that we can study here on Earth that helps us, gives us context for our remote sensing explorations out in the solar system.
Okay, well, once again, thank you very much, Dr. McFadden. And from all of us here at McREL and with the Dawn EPO, thank you all for joining us from out there in Webland. And we look forward to doing this in the future. Please check out our website, jpl.newroads. Sorry, newroads is the wrong thing. jpl.net. It's on the screen. There you go. So thank you all for joining us, and we look forward to talking to you again in the future. Goodbye now.